We look forward to a jam-packed program this year with the first Wednesday of every month. As usual, before we start, I'd just like to thank our sponsors. Firstly, Straight Nature. So Straight Nature is a leading specialist natural history publisher in Southern Africa, associated with the best-selling and most highly regarded field guides in the region. Straight Nature publishes full-color illustrated books across a variety of subject areas, including birds, mammals, reptiles, trees and flowers, as well as the marine environment, geology, astronomy, general wildlife, and of course, children's nature. And then Room to Grow. My name's Brett. I'm the owner of Room to Grow, and we've been designing and installing and creating outdoor living spaces in and around Cape Town since 2002. We offer a complete suite of landscape design, construction, and associated elements for our residential, commercial, and retail clients. And you can find out more about us at roomtogrow.co.za, as well as on our socials, Instagram and Facebook. And then I'm very pleased to welcome for the first time, and hopefully not for the last time, Dr. Elzanne Singles. Dr. Elzanne is a botanist and archaeologist dedicated to exploring the past and future relationships between plants and humans. She completed her PhD in archaeology at the University of Cape Town in 2020. Her research explores how the Cape Floristic Region ecosystems impacted human evolution. Currently, her time is split between consulting and research, and she is the sourcing director of Grounded Ingredients, where she and her team help develop sustainable and equitable value chains for products produced from indigenous plants, such as rooibos. She is a research associate at the Archaeology Department of the University of Cape Town and conducts private consulting services related to plant conservation, vegetation rehabilitation, as well as sustainable agriculture and archaeobotany. Her work is fundamentally driven by her passion for ecosystems of the Cape Floristic region and sharing that knowledge with the world to make it a better place. We're looking forward to this talk, and I ask that we will have questions at the end. So if you'd like to put those into the Q&A box during the talk, we'll have a session afterwards with Dr. Singles. And without further ado, Dr. Elzanne, we're looking forward to our talk. Over to you. Thank you so much.
Thank you. Hi, everybody. Thank you very much for this opportunity to present the very first Wednesday talk of the year. It feels like a very, very big honor. So as Brett said, my background first was in conservation ecology, and I transferred over to archaeology throughout my postgraduate research as I was pulled into research projects where they needed a botanist basically to look at the plant foods of the Cape Floristic region and quantifying them to understand how the vegetation of this region could have impacted human evolution. So that's really what this talk is about today. I'm going to give a brief background about the amazing archaeological heritage we have in the Cape Floristic region and the botanical heritage as well, but then dive deeper into my PhD research and my ongoing research that I'm busy with at the moment. Check they're not working. There we go. So before we get into the juicy stuff, I usually start off my talks with like a crash course of geological history, an evolutionary history of the Cape Floristic region. So for those that don't know, the Cape Floristic region is very, very old. So if we start from the very oldest thing, so the South Africa was part of Gondwana, the supercontinent that split apart in the Jurassic period, so a very, very long time ago. And fynbos started evolving in the Cretaceous. So fynbos is a very, very old type of vegetation. One of our most ancient ancestors, Australopithecus, evolved around 4 million years ago in Africa. And one of our close hominid ancestors, Homo ergaster, evolved 2 million years ago. And by the way, those are the first early humans that made it out of Africa into Eurasia about 1.9 million years ago. Humans only started evolving around 280,000 years ago. So we are a very recent feature on the planet, if I can put it that way. And today I'm going to be talking a lot about the Middle Stone Age and the Later Stone Age. These are two periods that we talk about the advancement of technology that we see in stone tools or other cultural evidence we can find in the archaeological record of advancement in human evolution. So the Middle Stone Age was a very, very critical period in our species evolution from 280,000 years ago to 50,000 years ago. And the Later Stone Age, there was a very rapid progression of technological advancements that we find in the archaeological record. So if you look at the figure in the middle, you can see in the Middle Stone Age, we did start to see very complex tools being constructed, hafting stone tools to spears, for example. And in the Later Stone Age, we also find a lot of ostrich eggshell beads for jewelry, for example, and lots of other cultural items, much finer arrow points, for example, as well. And then the Holocene is also a term, an epoch that we often hear about, which is the last 10,000 years. So I quickly also briefly want to describe these two images on the right. In the evolutionary span of Homo sapiens, so the last 280,000 years, the Earth has gone through a few very severe ice ages. And that is what this graph is depicting. In the last 140,000 years, a few very severe ice ages occurred. And during these times, most of Africa would have been a desert and completely uninhabitable, we think. And it seems like the Cape Floristic region was very stable despite these ice ages, and that people persisted here. So that's kind of the crux of why there's so much research going on in the Cape Floristic region in regards to human evolution. The bottom figure is the Cape Floristic region is this area along the southwestern part of Africa, but the submerged Agulhas Bank would have become exposed during these ice ages due to the ice caps getting bigger and the sea level dropping. And the area that would have become exposed is the same land area surface as the current Cape Floristic region. So this is what a lot of the researchers, archaeologists are interested in, is these periods in the Middle Stone Age where we see rapid progression of characteristics we think of as human coming up in the archaeological record during these times when this continental shelf was exposed. So a very different mindset to put yourself in, to think about the ancient history of this landscape and the journey that our species has walked on this earth. So I think many people in this talk, also seeing as it's linked to Kirstenbosch, probably know about our amazing botanical diversity in the Cape Floristic region. That's this area in purple, and the succulent Peru as well, forming part of the greater Cape Floristic region, is a hyper biodiverse and has one of the highest rates of plant endemism in the world. In other words, plants that don't occur anywhere else on Earth. However, I don't know how many people are aware of how amazing our archaeological heritage is in the Cape Floristic region. On the right are some of the archaeological sites that have sediments that come from the Middle Stone Age. In other words, humans were living in these areas, in these caves or shell middens, whatever it might be, during the Middle Stone Age. And that is quite phenomenal if we think about how few people on Earth there were at this time. And they were knocking about throughout the whole Middle Stone Age in the Cape Floristic region and the Later Stone Age, of course. So this slide is very dense, as you can see. It's a crash course again about the theories around why the Cape Floristic region was so important in our human evolutionary story. And all of this is still introductory to get to the juicy bits about the plants, specifically that were eaten, which is what my research is about. So due to the currents that come past the Cape Floristic region, it seems like the climate of the Cape Floristic region has been very constant, or relatively constant rather, for a very, very long time. And that's one of the reasons that so many species were able to evolve in this region, because the climate has been relatively stable in comparison to the rest of Africa and especially the rest of the world. Along the south coast and west coast, there are many very important archaeological sites that have been excavated in the past 40 years or so. But especially in the past 2 decades, I would say, there's been a lot of activity by archaeologists in sites. I was drawn into this world through the research that was being conducted at Pinnacle Point, just outside of Mossel Bay. And here on the right, you can see inside one of the caves, 60 meters of sediment that had, at that point, when I was helping out with excavations, had been excavated. So in other words, just going down into deep history. And through that research at Blombos as well and Klasi's cave, the oldest evidence of art has been uncovered. Here on the bottom are some beautiful shell beads that were created for jewelry. This Paramoon shell is the oldest artist palette that had ochre on it and even a grinding stone. You can see these beautiful, very fine stone flakes that would have been hafted onto spears. And of course, we also find a lot of fossilized bone from giant buffalo that were hunted, all kinds of amazing game animals that people were eating. But you also find so much shellfish. People were eating a lot of shellfish. These are the things, of course, that preserve very well into deep time. But with this flurry of research that has been going on into the significance of particularly the South Coast, in our evolutionary trajectory, the topic of the plants that were eaten started to also come up. And the idea that the people co-evolved with the plants of this region, and specifically my deep passion is for geophytic plants. So the plants on the right are the underground storage organs of plants. So the idea started to formulate that the special resources combination that we have and the climate being relatively constant in the Cape Floristic region allowed people to develop the traits that we think of as modern. So complex language, cultural significant practices like art, jewelry, whatever. This is a beautiful painting, a reconstruction, if you will, that was done for the research group that I've formed a part of for my postgraduate research. This is a reconstruction of what the exposed, submerged Agulhas bank would have looked like during one of these ice age periods. It would have looked something probably similar to what some of the flayland areas look like on today's Agulhas bank. But a few extinct mammals would have been knocking around, like bluebuck and giant buffalo. In the foreground, you can see women busy processing plants for the fire that's now just under the screen here. So I think this is a beautiful painting to really put our minds into a very different time to where we are now, you know, literally having a talk online. This is where our evolutionary background comes from. So what were plants used for in the Stone Age? Obviously everything. We didn't have any other means to, we had to make do with what nature provided, right? And nature provided a lot in the Cape Floristic region. So obviously wood resources were very important. We made tools like digging sticks and spear handles from plants. Medicine, very, very important. And many plants also were very important in rituals. But I'm most interested in the food, which plants were edible. So there's loads of fruits and vegetables, leafy greens that are edible in the Cape Floristic region, but a plethora of geophytes that are edible. So on the left are some of the fruits that are edible. This is also from a paper by one of our colleagues of the current knowledge of communities around Stilbaai. One thing I would like to highlight is proteas. Proteas, a king protea can have up to 2 cups of nectar in the flour. And sugar, glucose, straight glucose, was a very scarce thing in the ancient world, apart from honey or fruits. I think sugar would have been something that people really, really wanted to get their hands on. We see, of course, for people that hike, you would have seen how destructive baboons are in foraging for protea nectar. They rip the trees apart to get to that nectar. So I think that's pretty cool. On the right is a figure from a recent paper of mine. So these are the different types of groups of underground storage organs that we see that people would have eaten in the Stone Age. So bulbs, very watery, which is great if you're thirsty, but it doesn't have a lot of energy. Corms from especially the iris family were the very dominant thing that people were foraging, and some rhizomes and tubers as well. So why are the geophytes of the Cape Floristic region so special? Due to the climate of the Cape Floristic region, we just have the most numerous species of geophytes, even when comparing to similar climate regions. So all of the Mediterranean climate regions, where you see the similar type of evolutionary history as we do in the Cape Floristic region, our species diversity of geophytes in comparison to the surface area of the Cape Floristic region is quite literally off the charts. So we have 2,200 different species of geophytes, which is astounding. So geophytes as a food resource, they are a particularly great food resource. They are very drought tolerant because they've evolved to survive the harsh summers and survive fires by going dormant in the summer in general. We also know that they persisted through these ice ages as well because of the age of fynbos diversity. They're very rich in carbohydrates, especially in starch, which is something that provides a lot of energy, particularly breaks down into glucose, which our brains need. To this day, geophytes are a staple food resource in most hunter-gatherer societies, apart from on the poles where plants aren't as important food resources. Unfortunately, the evidence of their use doesn't preserve very well in the archaeological record. On the top here is what we find in the archaeological record in the later Stone Age, especially during the Holocene, so the last 10,000 years. So these are the husks that form outside of the geophyte or the corm. These look like Cyanella and Babiana. And this is the parts that would have been discarded and left behind in the caves, and that's what we end up finding. But as you can see, these look like herbarium specimens. They just dried out plant material. Unfortunately, this generally doesn't fossilize very well. So finding evidence of plant foraging in the Middle Stone Age is extremely rare. But we know from looking at extant hunter-gatherer societies and rock art, for example, that geophytes were a very, very important resource to the Sun people, definitely, to this day. So two archaeological hypotheses that I look at, that I'm very interested in for my research, is the seasonal mobility hypothesis. So this is something that my supervisor, John Parkington, really looked at since the 60s, about the cyclical nature of people's migration into the Cederberg on the west coast and back to Elandsbaai along or Lambertsbaai along the Olifants River Valley. So the thought is that when geophytes emerged during spring in the Sandveld along the west coast, that people would have migrated down to the coast and lived in Elandsbaai Cave, for example, and during summer migrated back into the mountains where the heat or the dryness of summer wasn't so severe in the mountains. The other hypothesis is really this idea of how important the Middle Stone Age was in our evolutionary trajectory, and particularly the South Coast, this submerged Agulhas bank. What was going on there? So this image over here is a vegetation reconstruction after many, many rounds of different modeling, geological modeling, edaphic modeling, of what the environment would have been like on the now submerged Agulhas Bank. So the idea that the geophytes, game and shellfish drove the development of modern traits that we think of as modern human traits. So with my research, and today particularly, I'm going to discuss these 5 questions. How common are geophytes in the archaeological record? How many people could this resource support? How nutritious is this food? And how does it vary seasonally? And how could this food be made tasty? And lastly, the most important question that all of these questions will lead to is, did this food impact our cognitive development and mobility? So I looked at more than 60 different archaeological sites across the greater Cape Floristic region. And in 60% of them, there is evidence of geophyte foraging. So there's evidence of some kinds of geophytes being left behind by humans after they had eaten the USOs, the underground storage organs inside. So at the bottom, you can see some of the evidence that I sifted through in the sites that I looked at, the archival material that had been removed from archaeological sites in historical excavations. Over here is the corm of a Watsonia, a type of iris that was bitten into and then dropped back into the fire. So it was probably horribly bitter, or something with the processing didn't go right, or somebody was just full or something like that. Over here is the knotted tops of some geophytes that were then just chucked in the fire and popped open and the corms eaten. On the right is a Morea, the top of the husk around the corm, that you can also see is charred completely at the bottom, and the nut-like form inside just popped out. So these are the different archaeological sites where I sifted through the archival material to identify the different geophyte species that had been foraged. And these are the ages of the sediments associated with that material. In other words, most of the archaeological sites I looked at had a very dense evidence of foraging for geophytes in the last 2,000 years. Some very rarely went as far back as 12,000 years. But again, this is remarkable if you consider that this is just dried plant material. The fact that there is anything left, even 2,000, that's 2,000 years old, is absolutely incredible to me. It blew my mind when I first started looking at this material that looked like it could have come from a fresh plant almost. So next question, how many people could this resource support? I found that in some areas, you can see this big square over here in the South Coast, for example, could have supported up to 4,500 people for a single day per hectare. So this is not a perfect metric, but it helps us to understand just how much food was there. This is similar to a wheat field. So the yield of these hotspots especially, so the bottom picture is a very dense stand of Watsonias, and these are the corms of the Watsonias, what they look like. So they're very, very big and very nutritious. So an area like this is, for example, what we're talking about when we're saying it could have supported 4,500 people per hectare. However, you'll notice on the right, in autumn, there's very little geophytes available because they are dormant. The exception is the South Coast that enjoys some rainfall in the autumn months due to cut-off lows, and that there are some geophyte species that have evolved to sprout out during autumn. So it seems like the South Coast in the current climate has more seasonal availability of this resource than, for example, the very harsh summers experienced on the West Coast. How nutritious is this resource? So I got to do a lot of nutritional testing on many, many, many different species of geophytes, which had never been done to this extent up until I did my PhD research. There's very little information about the nutritional content of plants available in the academic literature. So on the left is all the different species that have a higher nutritional content than a potato. So you'll notice that not only is the energy content very high, but the starch content is double that of a potato. So these species here at the top are very, very dense in starch. If you eat them, your teeth stick together because of the starch. It's like gummy almost. There's so much starch in it. So this would have been an amazing energy resource. However, if you look at this graph over here, like I said earlier, bulbs don't have very high nutritional content because they don't have very high starch content. Most of the species that are very, very nutritious are in the iris family and have corms. So the variability amongst the different species of the nutritional quality is very, very different. Apart from the energy content, some of these species also have very high fiber content, and fiber in an ancient context, people were not looking to have more fiber in their diet. They had plenty of fiber in their diet. So fiber would have been not a desirable trait in geophyte, for example. I also wanted to answer the question of how does this resource vary seasonally throughout the year? So geophytes have evolved to go dormant during summer. If we look at the context of the West Coast, for example, in general, the trait for geophytism has evolved to sprout when it rains, flower, seed, get your business done, go dormant and survive the summer until the rains return and you can sprout out again. But not only is there this seasonal phenology of the different species of when you would literally be able to see them above ground, I wanted to also know how did the nutritional quality of the underground storage organs vary across the growing season of the plants. So on the left, I looked at the phenology curves of all the different species that I identified in the 3 different regions that I studied. And on the West Coast, of course, as the literature also tells us, there's a peak of species that are apparent above ground during winter and spring, and nothing's going on in summer. So very few species you would actually be able to see over December, January, February. So this is for the coastal plain of the West Coast. For the South Coast, like I mentioned earlier, the South Coast enjoys some rainfall in autumn, which creates this peak in autumn of some species that are actually extremely nutritious, like freesias, that flower in autumn. So the South Coast has these 2 peaks similar to the West Coast in winter and spring, and then in autumn. The eastern part of the Cape Floristic region, so towards PE, the rainfall becomes actually more all-year rainfall, and the geophytes are very confused. So there's a lot of geophytes in this region that are actually perennial, so they don't die back, they don't go dormant. So the phenology curves for the East Coast was just a mess, to be honest. There are geophytes seem to be available at most points of the year, but their nutritional qualities don't seem to be very high throughout the year. So I tested the nutritional content of 4 different species throughout their growing seasons, or the months that they are growing, that they have apparency above ground. And in general, I think the Watsonia mariana results are very telling. When the plant starts to flower or leaf, it starts to put energy back into its newly developing form, and the energy content starts to rise. As it flowers and seeds is sucking back energy into that process. It's a very expensive process for the plant to go through. And we see a slight drop in the energy content. After seeding has occurred, the plant can focus on building up its reserves again for the dormant period it's going to enter for summer. So we find generally that the nutritional content is very high after seeding, especially for something like Watsonia that has a very predictable phenology curve. It emerges, leaves, flowers, seeds, and goes dormant. I also looked at what happens after the plant is gone above ground. So after the leaves have disappeared, and you can see in just the photos of what the corms look like towards the middle of summer, because the plant is just it's in survival mode, it's almost like it's in hibernation mode. It is building up metabolites from that process, and especially tannins. That's what this is causing this red color. And by this point in January, that thing is just like a spongy mess and very, very atrociously bitter. Here is just one example of a species that I looked at and identified in the archaeological record. These are beautiful Babiana hirsuta. They occur from Velderif up to Lambert's Bay. So here at the top are the corm discs that grow below the corm of from Elzanne's Bay cave, and these are 4,000 years old. And here at the bottom is what this looks like in a fresh mode. So here are the old season's growth that grow below the new season's corm. And on the right is the part that would have been eaten, that of course is very rare to find in the archaeological record because people ate it. So what I was able to also do from having to dig up so many of these geophytes and measure them and weigh them and send them for nutritional testing, I was able to find this pattern that as the new season's growth starts to emerge and build a new corm, the old season's growth starts to get flatter and flatter and flatter, as you can see in this illustration that I did for my thesis. So by the time that the nutritional quality and the weight of the corm is at its peak, the old season's growth is very, very, very flat, sometimes just a millimeter thick. And I was able to make this prediction of when, so based on the discs that I found in the archaeological record and measuring them, I was able to come up with a crude prediction of when that corm was foraged. So on the left is the results of that regressions that I did. So for the different archaeological sites, this evidence pointed to the fact that people were foraging predominantly in late spring, which is contradictory to what had been thought, that people were actually coming down to forage predominantly in early spring. And I also found that the variability was massive. So for Diep Kloof, for example, which is also close to Elzanne's Bay, I found some discs that seem to have been foraged in very early winter, so in the middle of the winter. And for the Eastern Cape, where there's an all-year rainfall, it seems like most of the geophytes that I identified were foraged in very, very late spring, actually early summer. So this is very, very early research, but I'm hoping to explore this pattern more in my future research, because it's a very important tool to test the hypotheses about seasonality of people's movement, for example, and where they were moving to for which resources. So the last question, the biggest question, is, did geophytes impact our cognitive development and mobility? I was always very interested in the idea about fire stick farming. Fire stick farming is a practice that I think was first described when early colonists observed Aboriginals in Australia setting fire to manage the areas that they were living in. So fire stick farming is thought to be the earliest form of land management. The idea of humans managing fire for their own benefit is a very old idea, but this amazing researcher, Richard Wrangham, also has published a lot of work about how important cooking and using fire for cooking could have impacted the trajectory of human evolution. We also have evidence from the Cape Floristic region that the fire cycles were influenced by humans. That it seems like in areas like Sedgefield, for example, where they've been able to do peat cores in the lakes, there's evidence that humans were setting fires. And then in 2018, during my PhD research, my friend Roshana from Felton Sea had a fire at their property, a devastating fire. But she called me to come and look at what had happened to the Watsonias. So this is a Watsonia corm that you can kind of see a smoke ring on. So the felt fire that had gone through had somehow smoked this corm inside of its husks, and she ate it and it was delicious. Normally these things are atrociously bitter and you need to do all kinds of leaching and salt and ash and all kinds of things to make it edible. But these were absolutely delicious. So it sparked my last chapter of my thesis very late in the game to try and look at what the different types of processing methods that are found in the literature and that were observed by early colonists, for example, what their effect is on the nutritional quality of the geophytes. So I focused on Watsonias because they are by far the most common and widespread species or genera found in the archaeological record. So in the literature, we know that some people baked Watsonias in ash and on fire. From Polynesian cultures, we know that a lot of food that have toxins in them are leached in salt water or in rivers. So I tried all of these different methods. We know that people ground Watsonias into a cake and then bake that in ash as well. So on the right is the tannin content, so that component that makes the Watsonias bitter. And here are the control results. You can see that it varies a lot, but there's a lot of tannins in Watsonias that are raw. All of the methods, apart from leaching in a river, had dramatic improvements to the tannin content of the Watsonia corms. But I can promise you, at this tannin level, I could not consume these Watsonias, and I have a very high tolerance for bitter from doing this research for so long. The felt fire reduced the tannin content to 0. So the sensation that Roshana and I had from eating those corms was 100% correct. There was no tannins left in those corms and they were delightfully edible. So the argument could be made that people set light to the felt, which had many other advantages as well. For example, for just ease of mobility, flushing out game, getting a flush of grass in to attract game later, all kinds of benefits to fire stick farming. But this was a benefit that I was not expecting to uncover in my research. This event was so pivotal in my PhD journey, I went on a little bit of a tangent. This glue substance that you see coming out of the corm, I was very interested in what that was. So I was very fortunate that at the time I was doing my PhD, Benjamin Scoville was also doing research at the archaeology department. And he's a stone tool expert, especially the process of hafting stone tools, so gluing them onto spears to make projectile weapons. And he had this machine that could shoot a spear at a controlled rate, a constant rate. So we formulated the idea that I would make hafted spears with this glue from the Watsonias, and he would make hafted spears from the glue that we know was used as a glue for hafting from Vachellia Karoo. And we then fired those spears into a rack of ribs, pork ribs, and all of the spears worked just as well. There was no statistical difference between the two different glues that were used for hafting. In other words, this glue could have been used to haft spears and create tools. So conclusions of my PhD and things I want to work on more, but geophytes were certainly a critical food source in the Stone Age. But there are many, many caveats to that statement. You need to be a botanist not to poison yourself, and to remember where all of these lovely hotspots are of very dense stands of geophytes. You need to be an economist not to starve. You need to be a chemist to eat well, to understand the nutritional content and when it would be most edible and what you need to do to make it more palatable. So I make the argument that geophytes very likely did make us smarter and affected our mobility. So to be able to leverage this incredible resource, people would have had to be incredibly, incredibly smart. So I quickly wanted to, at the end of my talk, just mention the booklet that is going to be advertised next. It was produced from my work with Kwatu. Kwatu is a San Cultural Heritage Center on the West Coast, just outside of Uitserfontein. I've been working for them for about 4 years, and I worked with them in lots of different ways to incorporate archaeobotany into their offering. So the booklet is one of the things that we produced from this collaboration. I also developed a tour for them, the First Peoples tour, which I highly, highly recommend to go and book that tour. It will discuss more in depth the archaeological record of the amazing archaeological sites along the Cape Floristic region. And then you can go to the restaurant and enjoy some indigenous food. Yeah, that's it. So the book will be available from me, and you can also get it straight from from Kwatu if you would like.
Sure. Thank you so much, Dr. Elzanne. That was riveting. It's such an interesting topic, and I'm sure we've only just scratched the surface of what's to come. We do have some questions, as you say, everybody. The link has been put there, or the information as to how to get the book has been put into the chat box. So, and it will be made available also with the recording after the talk. If we could go on to some questions, we do have some here. Firstly, Anna-Marie has asked, do you have any suggestions, but not too academic, for reading material about the timeline of plants and humans in the Cape in the Cape landscape?
Let me look at my bookshelf quickly. So I love, there's in the Kirschenbos bookshop actually a few books that discuss the history of the Cape Floristic region, specifically targeted to plants. One of my favorite is a book by Skeed, Historical Instances of Plants. So that's a great one that captures all of the early colonists' observations and interactions with plants, and very often that includes then their observations that were made of cultural practices around plants. So that's an amazing one that I could highly recommend.
Right, thank you. Jean or Jean has asked, do Chasmanthe corms fall into the same sphere as the Watsonias?
Very, very good question. So Chasmanthe is one of the species that you would have to look out for. Tannins are not poisonous, but Chasmanthe have secondary metabolites that do seem to be quite toxic. So it was one of the things that I was very interested in figuring out, because they're so common and very big and very nutritious based on their starch content, but they are unfortunately poisonous.
Good information. Colin, thanks for your link for the YouTube video. People can find that there, saying that there's a YouTube link on several aspects of this historical period that was dealt with during your talk, so that'll just help people give some background. Alistair has asked her, what other types of important nutritional elements do we find in Watsonias?
So in general, geophytes don't have very high vitamin content or micronutrient content. Tannins actually are very beneficial for our health. But predominantly geophytes contain the macro nutritional content that we require in the forms of especially the carbohydrates. So for the other micronutrient content, people would have relied on berries and leafy greens that are extremely nutritious. So the berries and leafy greens that I shared in an earlier slide do have very high vitamin C, all of the vitamin E, all of the different vitamins and minerals that we need.
Well, is there a potential then to farm geophytes, or is there any kind of potential in that market?
This is something that I think about all the time. I don't think that in the construct of our industrialized agricultural system that geophytes really stand a very high chance of being farmed. But you never know. If climate change really wreaks havoc with our climate and wheat can no longer be produced, maybe the plowed renosterveld fields will go back to the renosterveld full of geophytes.
Yeah. Nathan has asked, many geophytes contain secondary metabolites which are toxic, e.g.
Yes.
Cardiotoxic glycosides. How did the early Khoisan decide which were safe to eat?
So I think a lot of the knowledge related to foraging would have been in people's minds. This is one of the reasons that we think that language evolved, was to be able to share knowledge and teach one another. So that's number one. Number two is that our sense of taste is actually quite remarkable in identifying poisonous things. So tannin is one of those things that you get that aversion to it because it's so bitter. But many of the secondary metabolites actually do taste bitter. So I've also observed people just, putting a little bit of their tongue on the geophyte and just tasting if they're not sure. But this is certainly knowledge that would have built up over generations and generations.
Of course. Ronnie has said here, the archaeological records, do these show differences in plant development compared to the same plants today? Yeah, so I suppose that's the idea. Are we still dealing with the same types of plant species as we were 4,000 whatever years ago?
Yes, definitely. What we do know is that during ice ages, the CO2 levels in the atmosphere would have been far lower. So the rate of growth of geophytes would have been lower, and plants in general. So that is something that we do know. But the same species, we know also from phylogenetic studies, have been around for the entire period that humans have been around. We are a very recent feature in terms of an evolutionary timeline of how old the species of plants are in the Cape Floristic region.
Okay. Interesting. Adam has asked you, regarding the periods in the Middle Stone Age when Africa was largely arid, where on the continent did humans survive during these periods? Surely there were areas of rainforests in the Congo Basin that persisted during these periods and could have supported people. Or was it only in the Southwestern Cape that people survived?
So as I was describing, it seems like the Cape Floristic region was a refugia of this climate that was relatively supportive of humans to still exist here. There are other sites in Africa. For example, there's research being done in Botswana around the Delta and around lakes that shows that people were also knocking about there during these periods. So certainly, I think there were these little pockets of refugias all over Africa. But genetic studies indicate that all modern humans our lineage is derived from genetics from Southern Africa. So from Botswana, South Africa. So even if there were people in the Congo Basin, it doesn't seem that they survived or intermingled again with Southern African genes before we made it out of Africa.
Got you. Okay. Amber's questioning about are you basing your research, your movement research and plant gathering on current weather patterns? And if so, how do we know that the weather patterns have not changed immensely over the years?
So my research is absolutely based on current climatic conditions. I form part of the research group that conducts very sophisticated modeling to understand and import my information that I've gathered about the current climate and model it and adjust it to different climates in the past. So as you saw, most of the evidence of geophyte foraging is within the Holocene, so the last 10,000 years. And we know that in the Holocene, the climate has been relatively similar to what it is today, apart from the recent climate change.
Sure, got you. Nathan again says he can understand that many tannins are water soluble and therefore soaking in water would reduce the bitterness. What mechanism accounts for the reduction of bitterness when heated? Is it oxidation to less bitter substances?
I would love to know myself. So this is one of the things that I'm hoping to do in my future research, is to be able to test for more secondary metabolites. I didn't have enough funding to do that. And to really understand the chemical process that's going on. I just made the observation, and now we need to investigate further. So I think there's still lots of room for research for my career.
Fantastic. Anna-Ree's asked again, is there a chance that people may have farmed any of these species in the past? I know you were suggesting that it's possibly not viable nowadays, but is there any evidence to show that that has happened?
No, there isn't. In general, the idea of ownership, doesn't seem to have been ingrained in early human culture. The idea of just moving around for seasonal resources, I think, was much more alluring, especially just because there was such an abundance. I don't think farming was required. Yeah, so there is ideas around there. I know there has been research done on the biodiversity around cave sites changing, just from plants being transported in and out and seeds falling. Or I definitely think humans impacted the dispersal and ecology of the plants that they focus their foraging activity on. But that could, in a certain way, be seen as farming, right? It is like changing, altering the natural state of a species.
Interesting. That sort of tracks. It makes sense if you think about it in terms of the lack of ownership and just moving material around. You would have changed things inadvertently, not necessarily as a planned activity.
Yes, exactly.
Andrew's asked you, in the significant archaeological sites, is there any correlation with fossil pollen and the coinciding with evidence of geophytes in our diet, and indeed in the support of a modified fire regime that might have seen them proliferate?
Very interesting question. So two of the areas of archaeobotanical research that's really flourishing is pollen research and phytolith research. So phytoliths are silica molecules that are very species specific, that also preserve very well in the archaeological record. Pollen in general is an indication of the atmospheric, obviously pollen is everywhere in the atmosphere. So pollen research is more based on what the climate was doing and what vegetation was around during different periods. It's not so much useful when you're looking at what was forage. Phytoliths, however, show up in the archaeological record because the plant material was brought into the cave. So phytolith research is really, really starting to show very deep time relationships between humans and plants.
Wow, interesting. So I misunderstood Ronnie's question. He said his question was slightly different. He says, take a Watsonia, any difference between its archaeological record and today, and if it is, what was the possible reasons for the change? So is there any actual difference between specific species such as Watsonia between the archaeological record and what we find today?
No, not really. That I could discern from looking at these old things. In general, the measurements of the discs, for example, were absolutely comparable to what modern plants that I dug up and measured. So we also find that there's a very strong correlation between the species that are identified around a cave and what are the species I found inside the cave. So very likely in the case of like the Babiana hirsuta outside of Elandsbaai cave, it's growing at the mouth of the cave still today. So that population was likely foraged for thousands of years.
Good. Hope that helps, Ronnie. And then a last one here from Anna-Ree. Is there any evidence of the oxalis bulbs used as food in the past?
Yes, very, very commonly oxalis. I identified oxalis bulb scales, especially in the Western Cape West Coast sites. Very interestingly, one of the sites I looked at is up in the Richtersveld, and oxalis and Morea were the two most common things that I found in that sediment from that cave.
Oh, there you go. Well, we've come to the end of the questions. I'd take this opportunity to just thank Belinda in the background, to say thank you very much to Dr. Elzanne. It was a pleasure having you here. So interesting, and we really look forward to having you back when there's new information and new research to share with us. Thank you to everybody from joining us from all over the country, from around the world. We look forward to connecting again at the beginning of March. Thanks, everybody. Have a lovely day. Bye-bye.